Afternoon to one and all. So we welcome our speaker once again. And so hope you have your breakfast, lunch for your body. And let's have the lunch for our brain now. So in the morning session, we have heard from Dr. Sarath regarding various air emission database management. So in this particular session, we'll be hearing from him about the transportation policy specific to the Indian context. So hopefully we'll be waiting for a couple of minutes before our speaker will start his session. So we welcome you, sir, once again. So, sir, you can share your screen. So we will be waiting for a couple of minutes for the participants to join. The participants, be ready with your questions. Do pose a question of any sort. There is no question called a right question or a wrong question. Question itself is a question. So it will give us a chance to understand the scenario as well as learn from you. And specifically, it will provide a platform for discussion. So which is the only segment that we should have in our life of growth. So database will be the source, networking will be the. So do ask questions either in the chat box you can ask, or at the end we have time for discussion, so you can unmute yourself and ask the question. So do get ready and frame your questions. So we'll welcome our speaker, Dr. Sarath sir, once again, and we request him to deliver his lecture.
Hi. So any questions at all so far from the previous session?
Sir, no, sir.
No? Okay. Okay, so it's a continuation of what I was discussing in the morning, and now I'll talk about transportation policy, and I also showcase some of the tools where some of the number crunching that I showed earlier that will come in handy, and see how if there is a policy, how we can translate that into numbers, because that's a very important task as well. So a lot of things that I'm showing you here are actually were published in this paper in February, very specific to Delhi's air quality and what happened over there for the last 30 years. Paper is online and it's open. So one thing I wanted to showcase is this graph, because I showed a similar graph for all India in the previous presentation. And this is the same type of graph, but this is very specifically made with Delhi's registered number of vehicles. So you will see that everything is growing very similar to what you've seen in the India plot as well, but the y-axis is obviously a lot more sharper. So in the Indian graph, the highest point was only about 6. So the whole fleet, some numbers have increased like 4 times or 5 times. But here we are also seeing some numbers have increased for 12. And that is from compared to 1993, this fleet has increased 12 times, which is 4-wheeler taxis. So the taxis, again, there was a cap in Delhi for the longest time, and when the cap was removed and the app-based taxi system has come in with Uber, Ola, and there are a lot of other new app companies are there. So they started growing slowly, and there was a huge sudden jump in 2012, 2013 with Uber and Ola increasing their fleets like really in big numbers. So we saw a big growth there. So if we were doing a 4-wheeler analysis, so we should definitely have a split between 4-wheelers for personal use and 4-wheelers for taxis. Then you will have different VKT functions and different emission factor functions, and then the policy questions can be answered. Now, if the vehicle fleet, 4-wheeler vehicle fleet is there but not entirely used, and everybody is taking a taxi, then what will be the impact of that on the emissions? If the vehicle fleet is actually 4-wheeler vehicle fleet is increasing like this, it has increased 12 times compared to 1993. Let's say if it doubles by 2030, from 2018, 2020 to 2030, if it doubles, but if the fleet is EV, now what will be the impact of that? So things like that, when one could easily evaluate. Same here, the green line is four-wheelers. This is all types of four-wheelers. Your small size SUVs, all of them. So it's increasing. So it increased about 6 times. Two-wheelers have increased about 5 times. You have a bus fleet. Bus fleet really hasn't. Again, it flattened out to 1. So if you see this big bump here, so this is the Commonwealth bump. So during the Commonwealth Games, buses were increased. So all the new buses that came in and the old buses were retired. So there were AC buses, non-AC buses, those nice Tata buses that came in. So slowly, Tatas were introducing their buses into Delhi system, and there was a big bump there. So the fleet actually increased like 5 times right before the Commonwealth Games. And after that, the fleet never really, refurbished or introduced any new vehicles into the system. So it literally, came down to the old size. So right now, the fleet is back to like 3,000 buses. So the one of the policy questions one could ask is like, why is this? Now, why isn't the fleet increasing as it should? Because there is travel demand. We can see from the two-wheelers usage and the four-wheeler usage, and even the taxi usage. No, the taxis won't be going up if there's no demand. So obviously there is a lot of demand for mobility. So why aren't we substituting this demand with demand from public transportation? So a policy question that one can ask looking at these trends. So I wanted to highlight this graph because it's very similar to what we have seen in the previous presentation, but very Delhi centric. So if you again, this is a Delhi case, but if we get information in a similar fashion, we can do something similar for Hyderabad or Mumbai. Mumbai will be a really excellent case study because the kind of transportation mix and the kind of personal versus public share is very different from a lot of other cities, and that actually dates back to 3-4 generations. Sorry, not generations, decades. So you will have a much different picture, and it will be really good to see what that case study would really look like. So I'll be drawing some of these examples from this paper and then drive the conversation forward. And if you have any questions, please post them so that we'll have a good conversation afterwards. So don't hesitate. And for even for the previous presentation, if you have questions, please post it. Yeah. So one of the things that keeps popping up all the time is what is the share of transportation in a city's pollution? It's really a big question. The only way to ascertain this is doing a lot of number crunching, like what I showed you in the previous presentation. The big schematic, the very in the beginning, you build a really good emission inventory. You have a good understanding of the meteorology. You combine that into a chemical transport model. You can then get the concentrations and source contributions. Or the other way is what these studies have done. These IIT Kanpur studies have done. You take a sample at different locations in the city. You take it to the lab. You do a chemical analysis, and every one of these sources have chemical signatures in elements and in ion shares. So I say elements, which are basically potassium, sodium, iron, manganese, silica, and all those things. And then ions is basically your sulfate ions, nitrate ions, ammonium ions. So you have those, and then depending on the ratios between each of these, there's a way to statistically ascertain how much of the pollution is coming from what source. So there are a lot of studies that were done in Delhi, and in fact, in all of India, if there are 100 studies done, as an example, 50 of those are done in Delhi. Sad, but that's the truth. And irrespective of the studies, there's a mental understanding that cities' problems are always because of transport. And invariably, all the interventions then focus on transport only for the city to solve. But as you can see from the share of numbers from different studies, transport is important, but it's not the source that's contributing to the city's pollution. So we should definitely focus on transport because it really interlinks with all the sources, but we really need to focus on the others as well. So in the Delhi paper, at least, so we looked at all the studies that were done since the late 1990s, and then we tried to build a share ratio, saying that, okay, has there been a dramatic change in contribution of different sectors? And the answer is actually no. And this is a summary table, but I encourage you to go and take a look at the individual studies as well. So transport comes down to 10 to 30%. So this variation is basically mainly comes from the fact that when you have a spatial and temporal variation in the emissions, as we have seen in the previous presentation. So you have hotspots where transport will be a big contributor, and there will be places where transport will not be a big contributor. So there is a variation. And depending on where you take the samples, of course, you will have a variation there as well. So if we collect a sample or do monitoring right next to the road, you will obviously get a very high concentration share from the vehicle exhaust because you're measuring very close to the source. So like that, all the other sectors as well. I would like to point out that even though this is not a transport theme, so these two at the last two, so even though their annual share is so small, 3% and 1%, if one start to look at how much coverage, media coverage that happens for these two is totally reverse. So as soon as the agricultural burning starts in the Indo-Gangetic Plain in late October, November, everybody talks about it, even though that's only a 2 or 3 week phenomenon. Even Diwali firecrackers, it's a 2-day phenomenon, and it contributes annually to only 1% of the story. But the kind of coverage that happens for these two is the reverse of what the shares are. We don't nearly give so much importance to the other source, which is a sad part. But still, transport dominates in all the discussions. This is what we call, this is a new program called R-ASMAN by the Delhi Pollution Control Committee. They do real-time source apportionment. The chemical analysis I just now mentioned, where you take a sample and do the chemical analysis for ascertaining the shares, they do this in real time every hour, and then these pies are posted online. So these are looking at last 3 days. This is from January, so the winter time. So you have the secondary aerosols and the biomass burning as big sources because heating demand is very high. People are burning biomass, so you have a lot of contribution coming from there. This is captured yesterday. So right now it's very dry, very clean. Temperatures are very nice, so there's not much of heating. Winds are not really blowing so hard, so there's not much of dust coming from the west reaching these areas. So a lot of the sources that we are seeing in the samples are very local. So when it becomes local, then on a daily basis, obviously your transport share, this orange pie, is obviously looking very high. So today on a normal day, when the pollution is like 50 micrograms, 60 micrograms, which is green for us in air quality index, your transport share is very high. But this is not, I want to point out that this is not a typical day. This is a seasonal day. So a typical day would be something that is on the left-hand side. So transport is important. There is no point about it. There is no arguing about that. But it is not the biggest source. But it is considered as the biggest source. And a lot of interventions do point to that. This is again the NCAP program that I mentioned. So as part of this, all the non-attainment cities were required to prepare an action plan. And if you look at the action plans, they basically, again, transport is the biggest share of policy interventions. So if we combine transport interventions that are there on the action plan, and for transport and the road dust, so that's 50%. And this is not typical. This is not just for the Delhi case, also for, sorry. So here, this is similar for all the other states as well. So if this is for Andhra Pradesh, they had a 54% of their action items are for transport. This is for Assam, they haven't included their action plans yet. Like for Bihar, 39%. So like this, so every state, you look at it, they're like very high. So this is Madhya Pradesh, again, close to 50%. So irrespective of the share of the pollution, I mean, this share has been really high. Action plan high, interventions are very high. So the reason why I'm pointing this out is like, don't blindly say that everything in the city should be focusing on transport. Try to understand what are the shares coming from other sectors as well. Then, proportionally, you start looking at all the action plans that will give us biggest bang for the buck. So I would like to go back to this this fundamental equation, because this is what will eventually drive all your policy interventions. Okay, so when you look at the supply side, number of vehicles, so what kind of interventions are there to reduce the number of vehicles? So here the number of vehicles is not about the point is not about, oh, let's ban people from buying cars or buying motorcycles, or we should not have buses. It's not about that. It is about number of vehicles on the road. People can buy a car, but let's find a way to make sure that the vehicle is not on the road like as much as it is right now. Okay, so how can that how can we make that happen? So if the car not has to be used, a motorcycle not has to be used, even though it's there in the system as registered, but we don't want it used. So what are the alternatives? Promoting public transportation aggressively. It can be buses, metro, subways, mini buses, or even paratransit. So where you have shared vehicles, even three-wheelers, for example. So how do we substitute the number of vehicles on the road? So there are a lot of interventions that one can introduce. So again, the next one is, again, vehicle kilometers traveled. Same thing. We can have a vehicle in the system, but we don't want it used. How do we translate that? So just as an example, can we reduce the demand for mobility, motorized mobility with non-motorized mobility? If we can we introduce walking and cycling as an integral part of the urban design, so that people actually, especially the small trips, 1 kilometer, 2 kilometer, 3 kilometers trips, can that be substituted from a motorized to a non-motorized transport? So you have options there. Emission factor itself. This is one of the questions Brijesh has asked. EVs. Now, at the local level, if we reduce the fleet average emission factor, we will obviously have benefits of that. And how do we promote that transition aggressively? So we have plans to do something in 2030, 2035, 2040, but can we accelerate that and make it happen in the next 2 years? If that can happen, what kind of changes can we expect? So again, just looking at this fundamental equation, each of these buckets, you can start asking for options. Now, how do we reduce number of used vehicles on the road? How do we reduce usage of those vehicles on the road, demand? And how do we reduce emission factor, fleet average emission factors on the road, so that eventually total emissions are reduced? Okay, so I'll go through some of the examples, and then I'll also go through some of the calculators that we have to evaluate these and make some case studies and stuff. So this is something that I mentioned in the previous presentation as well, that Delhi usually gets a better fuel grade, used to at least, a better fuel grade than the rest of the country. So when all the norms were known, early mass norms were introduced in 1990 to 1998, all of them were applicable only in Delhi, not for the rest of the country. Then BS1 was introduced in 2000, and BS2 only in Delhi in 2001. BS2 came nationwide in 2005, but the Delhi got BS3. Okay, so like this, BS4 introduced in Delhi in 2010, but all India happened only in 2017. So this was not really a supply issue, but it was just a policy intervention. So one of the things that we highlighted in our refueling paper that was around 2014, 2015 was that this bifurcated fuel standards was actually not good for for the emission reductions. If you start looking at the emissions perspective and the health perspective, it was not a good idea, and that basically helped us in accelerating this. So even this BS6, the original plan in the auto fuel policy was to introduce in 2025, but a Supreme Court order was passed somewhere around 2018-19, saying that no, if India is already producing Bharat 6 fuel and exporting, like why are we not using it for ourselves? Like why do we have to wait till 2025? So this was as part of a PIL, public interest litigation, and the Supreme Court basically said that nothing doing. If you're making and exporting it, then we should also use it locally. So that's why the auto fuel policy was accelerated, and from 2025 it brought down to 2020, and both fuel and the vehicle standards are now Bharat 6 from 2020 onwards. So right now we don't have this bifurcated mode anymore. Now when a new standard is introduced, it is introduced nationwide. One of the interventions, much talked about intervention, is a CNG conversion. Again, a judicial intervention happened in the early 90s, mid 90s. Supreme Court said that Delhi's diesel bus fleet is the biggest contributor for pollution in the city. We have to convert that into CNG so that the PM pollution goes down significantly, and it did. But the fleet size at that time was about 3,000, and sadly, it still is 3,000. At this juncture, I want to point out to a white paper. This was published during that Supreme Court ruling in the late 90s. So this is a white paper published in 1997 by the Central Pollution Control Board on Delhi's pollution. So in this paper, they basically literally said that by right now we are running about 3,000 buses. Sadly, same 3,000 buses, same number is in practice even now. So it is estimated that the year 2001, Delhi would require 15,000 buses to cater to the peak passenger traffic. So this was in 1997. They said in 2001, they need 15,000 buses. So you can imagine what kind of demand is there right now. And that 15,000 number never reached, sadly. So we feel that even today, if we can introduce 15,000 buses into the system, it'll be a big boost to big boost to how the mobility is practiced. And I think after Delhi, only 2 other cities come into the picture with very high share of public transportation, as Bangalore and Mumbai. And then Hyderabad probably comes in around 4th or 5th or something like that. So that did change. The air quality did improve a little bit when all the buses went from diesel to CNG, because they were used quite a bit, and they're diesel old buses, so it made a big change. But nothing really happened after that. Then everything started going up, and right now we are seeing a little drop in the Delhi averages, but we feel that this average drop is probably due to an increase in the spatial representation of the air quality data as well. So this is something that we are now working with some statisticians to figure out what is the actual drop in these numbers. As an intervention, at a local level, it's a great intervention. So you have diesel buses, and it's a big fleet. They do produce a lot of pollution. So in the late 1990s, obviously the standards were old. They were BS1 or no standards at all. So obviously the overall emission factor in the fleet was also very high. So that to zero for a CNG bus, it was a great improvement, but not a replicable improvement. So this was done in the late 1990s, but we haven't had a single city, another city in India, which could replicate what Delhi did. So we should take that as a policy lesson. Some interventions are really good, but it's really hard to implement it. Maybe sometimes not without a Supreme Court intervention. So in this case, if Supreme Court hasn't intervened, maybe this never would have happened. So there's another judicial lesson there as well. Then there was this odd even experiment that happened twice, once in 2015 January and another one in 2016 January, both times. And there was actually a third one as well in April of 2017, but nothing really happened at that time. So again, a good intervention, but completely backfires on you. Even before Delhi did, a lot of cities in for example, Mexico and even in Bogota, it was introduced. So people started learning, how to bypass that. So people started suddenly having two cars. So one is the odd car number and then another with an even car number. So they don't have to be stuck with not having any vehicle to move around. So even in case of Delhi, it's a very open call. So we really don't know whether it's a success or not a success. So it depends on how you look at these numbers. So if we look at these numbers from, let's say, on an hourly basis, so we see that during the daytime, so this is daytime. So during the daytime, there was a drop, okay, but in the nighttime, pollution actually increased. So this was because the intervention was only from 8 a.m. to 8 p.m. So people were actually leaving the house before 8 a.m. and then leaving the offices after 8 p.m. So we saw those instances as well. So we see that. But if the same data, looking on a daily averages, we notice that the pollution levels have actually increased. So it's really hard to say whether the intervention was a success or not. It entirely depends on how you see these numbers in different aspects. So we also did this intervention analysis of this in a slightly different way. So from again looking at the pollution shares perspective. So at least in 2016, in 2015, so these were the vehicle shares, registered vehicle shares, and the pollution emission shares were like this. So obviously your light duty vehicles and heavy duty vehicles, these are all diesel and mixed fuel. So you will have a much higher share of the emissions coming from them. So close to 60% of that. Same fundamental equation, vehicle kilometers traveled and emission factors. I'm just showing you a summary of this infographs that we made for the purpose. So from 8 a.m. to 8 p.m., the number of the vehicles dropped. So there were a lot of exceptions for motorcycles. So there was not much of emission drop that we saw from the scooters, motorcycles, but from the cars, at least the daytime only, not the nighttime. So we saw a 32% drop. And auto rickshaw demand has gone up. This was based on a lot of surveys. IIT Delhi and a few others have done this survey. They said that the overall, anecdotally, the taxi, cab, and auto drivers had made 2 to 4 additional trips per day. So that's a big jump. Anecdotally, also fuel stations observed a 20% drop in the number of cars refueling. So that we used it as a proxy for understanding. Obviously, cars have traveled less during the daytime. And the Delhi Transport Corporation, this is the buses, they basically said they made 40% more bus trips. This was based on their ticket sales. So that obviously more people have started using the bus. If we combine all this, so we notice that at least during the daytime, obviously there is a success when the overall emissions from the fleet have reduced. But when we start looking at it from the nighttime picture as well, or a daily average picture, things get little more complicated. So shall we say this as a success story or not a success story? It's completely up in the air. But it's a good intervention that we tested. But there were a lot of things which were not done to the full extent. So we also looked at if the city really needed to be successful, if this policy intervention needed to be fully successful, the city really needed to operate about 13,000 buses to cater to that 50% drop in this odd even concept. But they barely managed about 5,000 buses to run. So it's not even from this perspective, was this intervention a successful intervention or not? Again, it's completely up for discussion. Sorry, somebody had a question? No. Okay, so I'm going back to one of the slides I showed earlier for Patna from the previous slide, from the previous presentation. So we looked at this. These are the in-use vehicles that are coming, to the petrol station, and they're pumping it. And we looked at the age profile of these vehicles. So 90% of the motorcycles are already, they're younger than 10 years, only 11% there. Autos and tempos only 7% there. Cars about 17%, and the SUVs are about 6%. So if we ban these older vehicles, is there a benefit, or is it just way too much paperwork for us to all to handle? Again, the concept is good because we know that the older vehicles are not maintained well. That's why we have emissions. But if we have a good PUC system and we make sure that all the older vehicles are also well maintained, then do we need to scrape these older vehicles? Is that a benefit for the system or not? So this is something that's again using same fundamental principle of vehicles multiplied, the number of vehicles multiplied by usage multiplied by emission factors. We try to look at if we look at the share of these older vehicles, and if we really ban them completely, what kind of benefit are we expecting in terms of transport? This is in case of Delhi. Here, two things were considered: the petrol vehicles, 15 years margin, and then the diesel vehicles 10-year margin was used for calculating this. So overall picture, maybe we'll reduce about 5% of the pollution if we really ban every one of these older vehicles. But consider the amount of headache that we'll have to go through in the paperwork, and then making sure the vehicles are actually captured, taken to the lab, taken to the yard, and thrown away. So is that really happening or not happening? So is it worth it, this much of work? When if the system has only so little of the vehicles older, do we really need to do anything? So this is mostly from the passenger vehicle side, but if one starts to look at the concept of this, so older vehicles are polluting more, we have to prove. So I just put this simple calculator just to demonstrate the theory. So let's say fleet size is 100, and I think this is very much applicable for heavy duty vehicles. We really want to make sure that the numbers kind of come down. So if we say that we have a 15% of the vehicles, 85% of the vehicles are okay emitting, and obviously so 15% are what we call as super emitters. So we have these super emitters in the mix. And if the newer vehicles are traveling 30 kilometers a day, and the older vehicles are traveling, let's say they're also traveling 60. So that then okay vehicles have a emission factor of 1. So I'm not putting any units, I'm just using them all as fractions. And the older vehicles are are emitting 10 times more than these regular vehicles. No? So if I multiply all these, so I get the total emission share, and you have basically the share of this. So okay vehicles, 85% of the fleet is contributing to 36%, 15% of the super emitters are contributing to 64%. But there is a lot of range. If one said that, okay, older vehicles don't move so much, they're only moving 30 kilometers a day, then this share really changes. And if somebody said these older vehicles are not 10 times worse, but they're only 5 times worse, then the story again changes. So to get this kind of story before a policy is introduced, saying that, okay, we should just go for all the older vehicles and get rid of them, we have to have a method of calculations like these in place. One can use Monte Carlo simulations on top of this to see if the range of emission factors is from, say, 5 times to 20 times, and vehicle usage is from, let's say, 20 kilometers to 100 kilometers. And if this share of vehicles or super emitters from 5% to 15%, what kind of changes can we expect? If the fleet is already 95% okay, then do we really need to bother about the super emitters in the bigger picture? So one could play around with these numbers. You can build hundreds of scenarios and see does it make any sense. And if it may really make sense, of course, then make it a concrete policy and propose to the city and say that, look, super emitters are a big problem for you and you have to do something about it. So it's very easy to drive some of these policy questions also from simple number crunching and tell the story from there. So we find that when we're talking to policymakers and show them numbers, they actually are a lot more receptive than just telling us theory, saying that, hey, public transportation is very important, put buses. That we've been saying for 30 years, but nothing happened. So how do we change that? So again, so this is a scrapage program. Concept is good. Sometimes it actually works for some areas. Sometimes it doesn't. For heavy duty vehicles, it's a good interventions if you really go after the super emitters. But for passenger vehicles, things are usually very well maintained, even in the older phase. So it may not be a good idea to break our heads on it. But you have to do the number crunching to figure out whether it actually makes sense or not. We had the BRT concept first introduced in Delhi to make these special lanes for buses only, but not successfully implemented and used, not only in Delhi and also in other places as well. Even the cities which have done something, it's always has been pilots and for small areas, but not for more than that. So even in Delhi, it was only a 14-kilometer lane. Even in Ahmedabad, it was very small, 20-kilometer lane, I think. Indore, they did a roundabout in the inner circle, but not happened. Most of the time, the problem has been the enforcement. Only time this concept of BRT has been successfully implemented was for the Commonwealth Games. Close to 80 kilometers of the road was cordoned off like this in the picture on the right hand side, and there were enforcement people at almost all the intersections, which made sure that other vehicles don't come in. And for the important fact is they didn't build any new roads. They didn't have to cut off anything from the existing roads. They just put these orange cones all over, and 80 kilometers of the road overnight became a bus only lane, and it was a very successful program, but only lasted for 2 months. They didn't even think about extending that. So even here, if one were to examine from numbers perspective, what kind of benefits can we calculate from BRT? So you again going back to the same fundamental formula. So you have number of vehicles, usage, and emission factor. So this sheet is all for CO2 only. So instead of number of vehicles, here we actually started using modal shares. and trips per day and number of passengers and things like that. It's a slightly different mode, but the fundamental equation remains the same. So we wanted to see if people started to use less cars and they all took BRT buses via BRT. So this BRT can be just public transportation as well. But so what kind of benefits can we expect in terms of fuel consumption and even in the total CO2 emissions and the energy per trip and things like that. So if 10%, 20%, 30% of the car passengers trips per day moved to buses, what kind of benefits can we expect? So cars obviously has a much higher occupancy. So they will, if 30% of the cars go away, definitely you have a big reduction in the total CO2 from the fleet. Suddenly it gets locked up. So you can slowly do a lot of these scenarios. So again, these are all subject to assessments, right? So from a city perspective, you have to have a good understanding of your modal shares. For that, you have to do a good survey. And you have to, as part of that survey, you will also get the occupancy rates in different vehicles, trips per day, usage, and you can quickly build something like this. It's available on our website for downloading and playing with it. And you can do hundreds of scenarios and see whether it makes any sense. So we have something called a combo scenario where you can look at all kinds of things, BRT, motorized, non-motorized, and combinations of that, different percentages. This one doesn't have a solver function in it, like the way I showed in the morning, but now it's Excel, so you can just easily introduce a solver function as well and have constraints. So BRT, again, it's a excellent intervention, but personally, I would like to focus more on the concept of public transportation, like promoting public transportation and not just a special BRT lane. So if there are more buses that will meet the demand for mobility demand for the city, automatically we will have a big change in the local emission load and also in the local pollution share from transport sector. That's a definite possibility. And we can show that through a lot of number crunching as well, like I showed in the previous Excel sheet. Then you have the metro rail system, very similar to the bus transportation. So the system is there. So obviously it's certainly being used. Right now, close to 6 million passengers per day are taking the metro. And this is about 20% of the total passenger trip load, and this is very similar to Kolkata's metro share is also significantly high. Mumbai's share is like close to 50% of the share. So one of the things that's very interesting is the number of people, the kind of transport people use at the stations. So we started noticing higher pollution at the railway at the stations and around 1 or 2 kilometer radius of the stations because of this. Now people are taking these short trips have really increased because of this. I'm not saying that as a negative thing, but the kind of number crunching that we were doing earlier on spatially segregating where the transport is, so that kind of changes and this makes it a lot more local. So we have to increase the motorized transport emission hotspots within a 2 or 3 kilometer radius of railway of a metro station, a little bit more than what we were doing earlier. So it's a good lesson. And going forward, it has a lot of implications as well. So very similar to buses. This one doesn't have a provision for metro rail, but this BRT can also be considered as a metro rail and do very similar calculations on if more car people were going to a metro, what kind of changes can we expect in the overall system. That can easily be done. Another one is this Delhi Freight Expressway. This one originally surveys were done both by IIT Delhi and CSE, Center for Science and Environment. They basically said that there's about 5 years ago, the number of vehicles that were entering were close to 85,000 per day. These are all heavy duty vehicles, and through traffic was about 50%. So basically traffic, all those trucks were just going through Delhi, but they're not delivering anything. So which means that they don't really have a good reason to start polluting that. You know, if somebody's entering from here, it goes in and just going through this inner road and cutting across and getting here. So this is basically about 80 kilometers of vehicle exhaust in the system, which shouldn't have been there. So the entry fee was literally increased 10 times, and that stopped all the trucks from actually entering. It made a difference, significant difference. And the expressways, the eastern, the western expressways were opened about 2 years ago. They were fully functional. So that really made a huge difference in the overall PM2.5 emissions from the heavy duty trucks. So especially because the entry has stopped. Now the vehicles which have nothing to do, not delivering or picking up anything in the city's airshed, they don't enter at all. So one is the expressway itself. Obviously, they have higher speeds and people are using that. And the entry fee was increased. A fiscal incentive or disincentive in pushing them outwards. So made a huge difference. So from an emissions perspective, again, this is the old animation that I showed in the earlier presentation as well. So this load, especially these highway load that we are seeing here, this really dropped by 30 to 50%, and all of them went to the outer ring roads, and making a change in the overall pollution, PM2 pollution as well. So this is an excellent intervention, but again, it's an infrastructure dependent, very heavy investment and time consuming, and really benefits one part of the fleet, which is the heavy duty vehicles. But this is a special case of Delhi. Now, if you go to a place like, say, Kanpur or Lucknow, where there's only one highway and that's literally cutting across the city, so they don't have a choice, right? The truck drivers don't have a choice. They have to go through that highway. So you can't always keep constructing bypasses for every city. So this is some cities, this has a lot of benefits. Some cities, it's a very costly affair. EVs, this is again a great deal. So current expectations are that 25% of the sales are going to be EVs in 2024 for cars. So at the local level, there's a definite benefit, but at the CO2 level, it's a give and take. Some studies are saying that EVs are actually making more CO2 on a life cycle basis than the others. This was a study published like a couple of weeks ago by IIT Kanpur. But some studies say that that's not the case. So it's a complete toss-up. But from an air quality perspective, at the local level, if we are not making any emissions in the vehicle exhaust, that's a definite benefit, an immediate benefit to the local air quality. And this 25% of the sales in 2024 means the benefits of this will not be immediate because the size of the already existing fleet. So in about 4 to 5 years, because we see a vehicle turnover period in a place like Delhi or big cities is about 4 to 5 years. So we'll definitely see a change in the fleet average emission factors that's coming in. So again, in interventions like these, we can have a very simple tool that we can use to see what kind of benefits that we can expect. We have something called, another tool called, this is VAPES. Very simple, same formula, number of vehicles, vehicle kilometers traveled, and emission factors, multiply them. But here we introduce a little age split as well to see what happens to each of the vehicles. And there's a growth rate, the vehicles are increasing, decreasing. Again, this is a really simple example of some of the functions. So suddenly, let's say in 2025, there is a retirement age introduced for 8, and then so what will be the change in the number of vehicles? So that will actually get affected in the age splits. So there is a change there. So one could start looking at these, age mix of these vehicles. More newer vehicles are coming into the system, and then if the vehicle emission factors themselves get updated on a daily basis. Let's say new emission factors introduced. Let's say in 2025, instead of 4, it becomes 2. Then obviously your fleet average emission factor starts getting better after 2025, and you will have overall benefits in your total emissions. So we have this very simple tool to demonstrate just that fundamental equation that we have, and play with how do we, if you play with number of vehicles, what kind of impact will it have? So here these 3 numbers are getting multiplied, but each of these numbers is basically a combination of these age mix and survival functions and everything. So if let's say we manage this, let's say this is an example for cars, and they're traveling 60 kilometers every day, but in 2025 we managed to drop that to 60. So obviously your overall total emission loads will dramatically drop, and you will have a change there. But some of these emissions are still going up because the number of vehicles are continuing, they're growing on an annual basis. So you can do a lot of these scenarios. So if let's say this is the base case, copy current emissions as a base case. So this is the base case, and you create a new scenario, the one we just talked about. So it went to say 40. So this is go to comparison. So we'll see that, okay, that new set has resulted in a drop of so much emissions. So you go back and say that, okay, I don't want to do the VKT, but I want to do the retirement function. Let's retire all the vehicles older than 8. So you will see a change in the vehicles, change in the fleet emissions, and then you have a change. So if we retired all the vehicles older than 8, so obviously the change is not as dramatic as one was expecting. So this is an example. So there are a lot of intricacies there one has to play with. So you can, but do you understand the concept that at the end of the day there are 3 numbers, and we complicate this to a different level. You can make this into 10 vehicle types or 20 vehicle types, and then start playing with a lot of scenarios. So here numbers are looking at from a bulk perspective, but one could combine this with an annual basis calculator as well. We have different versions of this that we use for different cities. But the point is that you have policies. If we can combine this with some number crunching, we will be able to evaluate the true benefits of various interventions. This COVID-19 lockdowns have been a really great natural experiment because pretty much all the vehicles just went away out of the system. You will see that the NOx emissions, for example, there was a huge drop. There's almost a 50% drop in the NOx emissions. This is over Delhi's airshed, and this is primarily because all the transport has gone away. So this is a true example to show that if there are no local emissions, obviously we will have a lot of benefits to local air quality, both in terms of emissions and the total pollution levels as well. So for example, EVs, you are 100% eliminating all the local emissions, so you will have a lot of benefits because of that. And also, if you promote more walking and cycling, and not promote cars or motorcycles, you will have a lot of benefits of that. Same thing, if you promote more public transportation usage, either in buses or metros, you will have lesser cars and motorcycles. you will have benefits of that. So we can look at all these interventions. I think was the last slide, but I really encourage you to go to our website, and each of these tools are available online, so you can just download them. There's one on the dust calculations as well. I didn't really mention that in the presentations, but one could start looking at these are the fundamental equations again, but dust has a very slightly different set of inputs that it requires based on the road conditions, and one could start evaluating road dust emissions as well. And if more buses are introduced, it actually backfires in the dust case, because buses have a higher weight, and if they go at higher speeds, you will have it's revving up of more resuspension dust happens. So you really have to look at how do you manage the road traffic and road silt loadings on the roads and things like that. So there are a lot of interventions that one can look at. Yeah. Yeah, I think we should, I'll open it up to questions. Yeah.
So it's a very thoughtful session. So we have 2 questions coming up, sir. It's like, yeah, 4 questions are there. So questions are already in the chat box, sir. So the first question is, I guess, sir, am I audible, sir?
Yeah, you are audible.
Yeah.
Yes. So the first question is on what is the logic of the government, as we have metro now. We do not need buses.
Sarath, when you were talking about that number of buses, it stays the same in Delhi.
Yeah.
So I was at that particular time, I typed that question, saying that I think that the logic that the government is making, that since we have metro, why do we need bus? Because that kind of logic I see in many meetings. We have done this, so why that? So that's what I was curious. Why they are not increasing the number of buses?
So in case of Delhi Transport Corporation, they said mentioned many problems. So one is personnel themselves. So they don't have enough drivers and maintenance people to maintain the buses, so they can't really get more buses. And they also said that, oh, we can get more buses, but we don't know where to put them. So even though they own so much of outside land, that they can easily convert them into godowns and house the buses, make them into depots. But there seems to be a big pushback from the political will for the buses than anything else. Metros are definitely a big infrastructure project, so there's a big hype in ribbon cutting, so it becomes a big push for that. But metros is definitely not a reason that we should not have buses. Like if anything, buses actually cater more people locally than the metros, and a lot more accessible as well.
Okay.
So we have our second question from Rajarshi Bar. Cities like Kolkata, they allow heavy-duty goods vehicles like trucks during night. How does this decision impact overall emissions?
Yeah, so this is actually true for almost all the big cities. They have made this a collective decision. So the heavy-duty trucks can enter the city only from 9 p.m. to 6 a.m. So after 6 a.m., if they are still in the city's boundary limits, they'll have to stop their operations. So it helps us in a couple of ways. So this goes back to the health question. So because heavy-duty vehicles have a higher share of emissions within the transport sector, you basically want to cut down their emission load during the daytime when people are still on the road. So mainly to counter the exposure rates, this decision was taken a long time ago. So the heavy duty trucks, for unloading and loading, they should be operating only at the night time. So the emission load perspective, that hasn't changed. So within the 24-hour period, those emissions are still there, but instead of daytime, they're all concentrating on the night time. But the exposure rate perspective, So you have significantly reduced the people who will breathe those emissions, and all of that is happening during the night time when you are now sleeping.
The next question is from Hemaja. As mentioned, people started owning more number of vehicles to bypass. Could you please highlight if there is any policy which limits the number of vehicle one can own and contribution of such policies in decarbonizing transportation sector?
We are a very democratic.
It's like Hemajag, if you can unmute and elaborate on it, that would be great.
Sure. So thank you for the session, sir. You were mentioning that the people are owning more cars to bypass the odd and even thing. And as of now, per my knowledge, there is no limit on how many cars or vehicles one person can own. So if there is such limit be set in the policies, will that be having any impact in decarbonizing? This is just a thought process I got, and I want your insight on this.
So it has some effect. For example, in Singapore, it has been implemented. So if you are owning one car, even for owning one car, you have to pay 100% duty on it to get the license number. And if you want to have a second car, then you will pay like 500% duty on it to get a new license plate. So that really discourages them to get a second car. But a city like Singapore, or London, Stockholm, Copenhagen, even now in Beijing, Shanghai, you don't need a car. So the public transportation system is so well connected, so you can survive, having no motorcycle. Maybe have a motorcycle for short trips, but you don't need a car. So while you create policies to discourage people from buying one car, two cars, or three cars, that will be a successful program only if you have alternatives in place. So right now, a lot of our mobility demand is driven from a personal safety / comfortability issues than from environmental perspective. But there is no such policy. At least in India, we don't have any limitations on how many vehicles that one can own. In India, at least the odd even case was only for Delhi, that too for like 2 weeks, 3 times, and pretty much completely scraped off. Like nobody really talking about it anymore. I don't think it'll ever come back. So the example that I mentioned where people started to buy a second vehicle, a third vehicle, that's actually from Mexico, which actually had the odd even program in place for a much longer period than 2 weeks. So the period itself was so long that people started to look for loopholes and started getting second-hand vehicles. But at least in India, there is no limit. So that's why we want good urban planning in place, good transport demand management in place, so that even if you have a second or a third car, how do we discourage them from using it, so that your CO2 emissions come down, your air quality emissions, air emissions come down, and you have better air quality.
Sure, sir. Thank you.
So then the next question is from Rajashri Bar again. So did your study involve the emissions from hybrid vehicles in India? Also, does the Indian transport system contain a significant number of such vehicles to have an observable impact?
So we didn't very specifically have a category for hybrid vehicles. We could just put them in EVs and alternative vehicles, and we had a percentage cut of the emission rates that would come from them. But even Brajesh has mentioned earlier, the fleet size is really small now, so we can't really see a observable change in at least in the air quality from the current fleet. So we really need the fleet size to be at least 10%, 20% to see a significant change in the air quality.
So that ends the questions in the chat box. So we are waiting for the participants to unmute themselves and ask any questions.
This is Dr. Murali Krishna actually. Just Hemaja has mentioned that the vehicles registration, if anybody is having a second vehicle. In Telangana, what I understand is the same name, if I purchase a second vehicle, tax is little bit more, maybe 2% or 3%, like to discuss.
Okay.
That's why people use it to take on others' names, family others' names. Just I want to mention.
But it's still in the family.
Of course, of course.
Any questions? Yeah, do put forward some questions, so there will be a good discussion that will help in designing the strategies for the Indian sector.
So I see a question by Joydeepa. Ravi, there's a question by Joydeepa there on CNG vehicle. Just last but one.
Yeah. So what is your take on the impact of introducing CNG emissions on the overall CNG vehicles on the overall emissions as compared to diesel and petrol vehicles? I have a two-part answer for this actually. From PM and SO2 perspective, the drop in emissions is immediate. For when you go from diesel to CNG, there's almost a 95% drop. From petrol to CNG, there's almost a 50% drop in the total loads. For SO2, it's almost 100% in both the cases. One thing we found doesn't match is with the NOx emissions, because the combustion of CNG happens at a much higher temperature than petrol and diesel, so which basically translates into producing more NOx from CNG emissions than the others. And there are also cases of small leakages from the CNG vehicles, which means that you have some incomplete combustion and you'll end up having an extra potent VOCs coming out of the engine. So at least in case of, there's some case studies in US, even in China as well, they've noticed that with the increase in the CNG fleets, they notice more NO2 concentrations. And because of these leakages in the VOCs in complete combustion, they're also looking at some of the ozone exceeding instances are also going up. So on one side, if we focused on air quality, if we focus on only on PM 2.5, the benefits are immediate and substantial. For NOx, not so much, and the ozone, it's increasing on a long-term basis.
Okay. I do see a name here in the participant, Anand Surelia. I was just wondering, is it our batchmate? Is that we had a Anand Surelia? Anand.
Yes, this is definitely me.
Okay.
Who is this?
Hello?
Rajesh? Is this you, Rajesh?
Yes.
Oh, yeah, yes. Yeah,
Sir.
I got the link from our WhatsApp group, so I thought, why not just check?
Okay.
Hi, Sarath. It was a nice presentation.
Thank you.
So good. जब मैंने नाम देखा तो मुझे लगा कि ये coincidence तो नहीं हो सकता. आनंद सुरेलिया दोनों मैच कर रहा है.
There are not too many people for that.
So good that
There's another question here. So have you done any category of a type of petrol like normal, unleaded, V-Power and different brands? No, so we don't do any emission factor work. So that's something that we really don't have bandwidth for. It would be really nice if it can be done. So we haven't done any metal emission analysis. So for example, in the leaded and unleaded emissions, basically looking at the lead content. So we really haven't done any of that. The real-time source apportionment work that's happening, the R-ASMAN 2 pie charts from January and June and January that I showed in the morning presentation. So that system is tracking metals. So they're actually, if you go to their website, you can actually see the metal profiles as well. And we are seeing some lead still in the samples, which is very unfortunate. One would assume that the lead is completely out of the picture, but at least now the story is that that lead would probably be coming from the batteries, because this EV batteries, the small EV rickshaws that are running around, and they're always running on batteries only. So it's very likely there are some small leakages from that. So the lead is popping up in the samples. So we haven't done any of the differentiation work within the petrol categories.
So you are based in Goa right now, or you are in Bangalore?
No, I live in Goa, but tomorrow I have to go. Now, if that trip hadn't happened, I definitely would have come to Kharagpur.
Yeah, we will have, as I messaged you, like anytime you just let me know a window where you are relatively free to come.
Yeah.
And there's one more question here that can you highlight the significance of exhaust emissions on health during daytime and nighttime?
So this is the intake fraction analysis. I don't have exact numbers in hand, but if we look at the transport sector only, so you will have 90% of the exposure happening during the daytime, from a personal exposure perspective, and not like less than 10% happens during the nighttime. So this is again one of the significant reasons why that drove the need for having as much of the heavy duty emissions pushed into the nighttime and not have them during the daytime. So there's another study actually from University of California, Berkeley. They looked at a 100-meter radius, which is the most influential 100 meters distance from the main roads, which is the most influential area for road transport exposures. So close to 55% of population falls into that category. And so if in the daytime exposure rates. So that's one of the reasons why you have, at least in India, we have more daytime exposure to vehicle exhaust than the others.
Okay.
So this one, we haven't done that on aberration of vehicle tires at signals and while applying brakes. So the last Excel file that I showed you, it's called VDust, that actually looks at, let me quickly share the screen. So this one, so this actually is very specific to looking at brake wear and tear as well. So there are actually a lot of factors that you really have to get a good grip on. So what is the emission factor of brake wear and tear, and how that is as a function of the both vehicle kilometers traveled and the vehicle weight. So this is a good function to have. So there is no full understanding of this. Very few studies have been done on this. So there is we can vary this function to a degree and see what kind of impact it has on the total PM 2.5 and PM 10 emissions. So again, it's a very big function of the vehicle weight itself. So if we are increasing more buses into the system, while the vehicle exhaust emissions from the cars and the motorcycles and other modes will actually come down, but this brake wear and tear will definitely go up a little bit. But on a comparative basis, it's better to have this combination than the full vehicle combination.
So any other questions from the participants?
Yeah, any one of you who has any question, you can unmute yourself and ask as well. We have time.
Sir, I'm Rajarshi here. I had a question, like taking that point forward. supposedly there is an exhaust emission coming during daytime and nighttime. So sir, how can the climate or temperature conditions like you see inversion, like how whether the surrounding air is stable or not, whether the pollutants are getting dispersed in day and night as compared to summers and winters. So what is the impact of this particular aspect on human health and others?
Yeah, so that we have actually looked at. So if you look at paper, it has a significant impact. So we looked at the daytime and nighttime mixing heights. This has a very significant impact, and it varies very significantly over the season as well. So if we have same amount of emissions in the system, both daytime and nighttime, it will definitely have a much bigger impact. So just looking at January, your mixing height is double during the daytime compared to the nighttime. Nighttime is all day. Nighttime is like 10 times better. So which means your nighttime concentrations are going to be 10 times worse for the same amount of emission load. So if you, mathematically speaking, the concentrations are mass over volume. Mass is basically your emission rate, which you have both daytime and nighttime. Volume is pretty much driven by your airshed size and your mixing height. So if your mixing height is 10 times worse, means that your overall concentrations, 10 times less, then your concentrations are 10 times worse. So we do have this information. This is summary for the entire airshed of Delhi, but you can definitely go to our website and download these on an hourly basis for the entire districts of all the districts of India. So you can have a quick summary of this, and you can do some of the analysis.
So, sir, most of the cities, like you said, all the cities, they allow these heavy duty vehicles at night. So then I think, what is your take? Like, then does it need a bit more, a deeper analysis, because it is like a two-edged sword? If I am driving these vehicles at night, then that means that more of those emissions, they are staying around. So
yeah, they're staying around, but then as the morning break happens, we've actually seen this in the diurnal trends, in the diurnal concentrations, it disperses right away. So by the time your regular traffic comes in during the peak hours at 8 o'clock or 9 o'clock, you won't see that much of the remnants from the nighttime traffic. It does get dispersed. And because the loads themselves are lower, it's easier for dispersion of that.
thank you, sir. Thanks a lot.
Yeah, but as I said, the emission loads themselves are not changing. They're just shifting from daytime to nighttime. But from a overall exposure perspective, it makes a huge difference for us.
Okay, thank you, sir.
Sir, there is one more question from Sudarshan. Have you done any study with respect to air pollution impact in the environment with respect to abrasion of vehicle tire at signals and while applying brake?
Yeah, we answered that already.
Sir, this is Anand here. So from a summary recommendation point of view, if you were a policymaker, what would perhaps be like top 3 recommendations that you might try to implement based on, like, both from the impact perspective, but also from like how much achievable that would be?
The top 3 would be definitely promote public transportation to the highest extent possible. So, and you don't have to be very infrastructure heavy. It can be just buses and mini buses, so that you touch most of your origins and destinations within your airshed. That's very much possible to do. Your second, like really doable option is promoting non-motorized transport, like walking and bicycling. This basically targets your lower lower VKTs. So basically trips which are like 1 kilometer, 2 kilometer, 3 kilometers. So those can be easily converted into non-motorized mode. So in most of the cases, the issue has only been safety, especially for cyclists, for example. So if you create independent like cycling paths, then it really makes a huge difference, and it's completely doable. And then the third one is basically targeting the motorized transport. If you want to target the motorized transport, now a better option now these days looks like the EVs, because the fuel standard itself is already at Bharat 6, which is the best possible at the moment. So your next generation would definitely be going to zero emissions, that is your EVs. So the buses and mini buses will target your masses, like mass transport. That shift can come from all the modes. Your non-motorized transport will basically take care of all the low-end traffic, small VKT traffic, and your EVs will basically target for better technology.
Okay. And what about the emissions or the particulate emissions that you get from non-transport sectors, like construction and anything else?
That's a completely
because that is also
ball.
a huge. That's also a huge. I mean, that's probably a bigger portion than just the transport sector, right?
Yes.
Yeah.
When you asked the question, I thought you were only focusing on transport. But if you're focusing on non-transport sector as well, then there are like 5 different things that I would basically focus on. So you basically have a lot of waste that goes uncollected and unprocessed that really has to be taken care of. Because in most of the cases right now, in most of the cities, collection efficiency is like 50%, which means that any given day, 50% of the waste is basically burnt in different phases. And then you have the dust. So this dust is both your road resuspension dust from vehicle usage and also from the construction dust. Both of them collectively have a very large share, especially in the coarse PM pollution mode, the PM10, and that really needs to be tackled. The construction sites have a lot of norms in place in how they have to operate, especially the big construction sites. But when we've done a few surveys, and most of the time, maybe 50% of these norms are actually applied, and we see a lot of violations there. So we end up having a lot of that dust, and most of the construction activities are happening very close to the main roads, the main feeder roads, which means that dust is basically getting settled on the roads. Then you have a secondary resuspension happening when the vehicles move. So it kind of it's a double whammy there actually. The third one is basically greening. So we are seeing less and less trees, and a lot of trees are getting cut in a lot of spaces. If that greening is increased, it will definitely have a much bigger impact on air quality. Very simple thing. This was actually a study done in Leeds. They said that if the hedge the hedges around the houses were increased for like 2 feet, the exposure rates actually goes down by like 30% inside the houses. So if we have more trees, obviously you increase the breathing surface, the leaf area index in the city, and it has an immediate effect both on your overall dust levels and also on the exposure rates. Then you have the industries, and then you have to enforce more of the norms, and then the transport sector, the 3 that I mentioned, they really come into the full picture.
Okay, thanks, Sarat.
So there is one more question now on from Abhishek. Last one. Effect of high-rise buildings in urban areas in the dispersion of pollutants that has been during night period.
It does, but we really are not looking at that microphysics. It's a completely different, looking at this computational fluid dynamics and turbulence at such small resolutions. You really need a lot of computational space, and we don't have that. But it does have an effect.
So yeah, I think any other question from anyone? If not, then I think is anyone? Looks like somebody is trying to say something. Okay, if not, then thank you, Sarath. It was it's always wonderful listening to you.
Thank you.
Thank you very much. And next time it will be at campus. Just let
We'll-
me dates you are available. We'll plan something here.
Yeah.
Okay. Thank you.
Thank you. Bye.
Bye.